Hello everyone, this is Professor Chan from Math 1245 speaking. Today we're going to be going over section 2.5, which is transformations. Before we get started, one thing that we want to be mindful about is that you want to make sure that you know your parent graphs. So remember, your parent graphs are original graphs, and the examples that we had were lines, quadratics or parabolas, cube root, square root, cubic, reciprocals, and absolute values. Make sure you know the properties of those transformations and as well as the actual shape of them. And that's going to be very important for us later down the road for this section. Today we're going to be going over the basics of transformations. There'll probably be a second video up and it'll be a more detailed version of transformations itself. Okay, so before we actually do some of the more difficult problems, we want to make sure we know the general characteristics of transformations. Now, if you look at your textbook or the PowerPoints, one of the things you want to make sure is you want to understand what transformations are. Okay, and transformations that they state in the book is just simply a specific movement or change of your parent graph. So that could mean your graph is shifted up, shifted down, it's moved to the left, moved to the right, it can get flipped, it can get stretched, okay? But the one thing you want to understand and you must remember is that the shape of your parent graph will always stay the same, okay? So let me give you the first two examples, okay? So we have, if you look at the first part one is we're adding, subtracting inside, and we're adding, subtracting outside. Okay, now some of you guys are wondering what the heck does that mean? So this is what we're going to do. I'm going to give you an example of absolute value of x plus 2 and absolute value of x minus 3 inside of parentheses. Some of you guys may not realize this, but I'm going to show you how to graph absolute values, okay? You may not be familiar with this. So you're going to hit the y equals, which is what we've done normally. And to do absolute value of x, you're going to press the math button and then the right arrow button, which will get to the NUM or numerics. You're going to select option 1, which is ABS, and out will pop out your absolute value sign. Okay, now if you are using a TI-83 or a slightly older version of this graphing calculator, you may just see ABS. Don't worry about that. Just insert X like what I'm doing here. Okay, and I'll hit graph, right, and that is my absolute value. Remember, absolute value looks like a V. Okay, so let us graph some of these examples right here. So what I'm going to do is I'm going to graph inside absolute value of x plus 2. So notice if I graph it, notice my v goes to the left, right? So there's a shift to the left. And if I press second graph, I notice that my y's do shift to the left by 2, right? So notice I have my original ones, y is 3 when x is 3. Notice here my y2 is 3 when x is 1. So notice if I'm adding inside the absolute value, it's going to the left by 2. Okay? So obviously if it's negative, it's actually going to go to the opposite, it's going to go to the right, okay? Now, here's the thing for all of you, okay? It's really easy to kind of feel like you need to memorize everything. And for transformation, yes, there might be pressure to do that. But remember, you have your graphing calculator, so if you're not sure, test it out. So watch what happens if I do absolute value of x minus 3. Okay? So based on what we said, that it seems pretty obvious it's going to go to the right. Check it out. Notice if I graph it, you can see my absolute value goes to the right by 3. Okay? So it goes to the left if it's positive, and it goes to the right. Sorry. If it's positive, it's going to go to the left. If it's negative, it's going to the right. And remember, this is when it's in the absolute value of parentheses or whatever function it is. Okay? The other thing to take note is that notice my v doesn't change its shape, right? It moves to the left, it moves to the right, but it's still a v. Okay? And take mind of that. That is something that's going to be very okay. And this holds true with all transformations. The shape will always remain the same. Okay? The movement will change, but it will always be the same shape. So if I'm doing my transformations and I'm not getting a v for my absolute value, then that's problematic. Okay. So let me show you part 2. So I'm going to do absolute value of x plus 5. So notice I'm adding outside the absolute value. And notice it goes up, right? My v gets shifted up. And I can clearly tell if I go to my second graph, right? Notice everything is being added by 5, right? My original one is 5. Now it goes up by 5, which is 10. 4 goes to 9, 3 goes to 8, so forth. So if I'm adding, remember, outside of the parentheses or outside my absolute value, I'm going to go up by 5. Sorry, I'm going to go up. If I'm subtracting, it's going to go down, okay? And once again, if you're not sure and if you're not confident, test it out. You're like, well, what happens if I subtract 7, right? Like what we said right here. Notice it shifts down, okay? And that verifies what we have. Okay, so your graphing calculator, once again, your graphing calculator is very useful, okay, to helping you with that. Okay, so adding and subtracting does what's called shifts. So they either shift up, down, left, right if I'm adding and subtracting things. Let's talk about what happens if I multiply or divide by something. So we're going to talk about these three, number 3, number 4. Okay. Okay. So okay. So let's talk about this right here. What happens if I'm multiplying by a number out in front? So I have 3. Sorry. So I have 3 times the absolute value of x. Notice that everything's getting multiplied by 3. So it's getting up, it's become very narrow. This is what we call a vertical stretch. If I go to my table, look at what's happening. All my y values, right? So y1 is my original. y2 is my new one when I multiply by 3. Notice my y values are all being multiplied by 3. Okay, so if my number in front is larger than 1, we call this a vertical stretch. Okay, if I do 1/5 x, sorry, 1/5 absolute value of x, notice it becomes a lot wider. We call this a vertical compression. Okay. What is that? What does a vertical compression mean? Okay. It means you're kind of squeezing your graph down. So notice it's not, notice a vertical, notice like my new graph is a lot shorter, right? And it ends up being wider. Okay. Now, if I multiply inside, so if I look at part 4, if I multiply inside, let's say if I do 2x okay, what does it do horizontally? Okay, so b is greater than 1. Okay, in this case we have 2 inside the absolute value, then we have what's called a horizontal compression. What does that mean? We are saying that my graph kind of gets crushed horizontally. Okay, so in this case we say it's being crushed or compressed by a factor of 2. Okay, remember the compression and stretch is actually being multiplied or divided, not adding and subtracting. Okay, and then notice if I do absolute value of 0.25x, okay, I'm making something up here, my vertical compression, sorry, my horizontal is stretched out. So I have what's called a horizontal stretch. Okay, let's talk about this here. Okay, so you may, if you kind of like Google this, okay, one thing you'll realize is they're kind of essentially the same thing. If you think about it, if you're compressing vertically, right, if something is pushing downwards, everything, your object will essentially be stretched horizontally. Okay, so in other words, vertical compression is very similar to horizontal, sorry, vertical compression is the same as a horizontal stretch. Okay, and a vertical stretch is very similar to a horizontal compression. Okay, now you won't really need to worry about the stretch and compression as much, okay, but just make sure you kind of know how they relate to each other. Okay, now let's talk about this. If I change a sign of a, or if I change the negative in front of my absolute value, what will happen? So let's see. What happens if I do negative absolute value of x? Notice it's actually flipped upside down, okay? So let me erase this. So hopefully you guys already got this right here. Okay, so if I change the sign of negative f of x, okay, this will be flipped across the x-axis. So the idea is it's going to be upside down. Okay, if I change inside, it's going to be flipped across the y-axis. Okay, now here's the thing. If you have a hard time figuring that out, right? Remember what we did in the very first week of class when we were talking about symmetry, right? Remember, if you go from f of x to negative f of x, right, that means your y becomes opposite signs. If I go f of x to f of negative x, right, it becomes x to negative x, right? Just remember the symmetry across x-axis and y-axis, respectively. Okay? So let's just use some examples what this means, okay? So we're saying if we have 3, 6, what does this mean here, okay? So if I have 3, 6, right? And if I'm doing a transformation, right? So let's remember what this is. This is saying, right, this is flipped across the y-axis. So that means if I start off with 3, 6, so let's think about this. 3, 6, it's like right here. If I'm flipping across the y-axis, I'm going right here. So that makes this one negative 3, comma 6. Okay? So that is where my new point would be after I transformed it. Okay? If I am flipping across so the part B is actually going to be flipping across the x-axis. Be here. This will be 3 comma negative 6. Okay. Once I do, so here, this is what's called, right, a vertical stretch by 2, okay? Now, the thing is, you want to make sure not only do you understand the type of transformation, but you want to understand what operation is being handled. So if I'm doing a vertical stretch by 2, right, that means I'm multiplying my y by 2. So since I'm starting off with 3, 6, this now becomes 3 comma 12. Okay, and then lastly, if I take a look at part D, this is a horizontal compression by 3. So what does that mean? I'm dividing x by 3. So this will become 1 comma 6. Okay. The compression is a little confusing, right? So the idea is if you're going inside, here's actually a trick too. If you're doing any operation inside the parentheses, okay, it's always generally opposite of what you think it is. Okay, right? So normally we always think if we're like putting a number inside, right, we're multiplying, but it's actually dividing. And if I'm adding something inside the parentheses, that means I think it's going to right, but it's actually going to left. Okay, and once again, if you're not sure, use your graphing calculator to check. Okay, so let me do these last types of problems, and we'll just end the video here. The next video, we're going to focus more on the specific graphs themselves. Okay, I promise you this is going to make a little bit more sense in a second video. So let's take a look at this one, right? So I have negative 6 comma 2, right? So we want to understand what operation we're doing. So for example, this one, we are flipping across the y-axis. So that means, right, what does that mean? That means my x is changing signs, or I'm multiplying by negative 1. So this becomes 6 comma 2. Okay. Part B, let's take a look at this one here. I have a vertical stretch by 4. So that means I'm multiplying y by 4. So this is negative 6 comma 2. So this ends up being negative 6 comma 8 because I'm multiplying my 2 by 4. Okay. Okay. So let's talk about part D and E, okay? D and E can be a little bit confusing because what's happening is you have multiple order of operations, right? So you have multiple transformations happening. So you want to make sure that you do your operations in order. So the general rule of thumb is think of order of operations, right? So if I look at part D, I have 2 operations, right? What are my 2 operations? I have, if I look at D and I'm gonna kind of order them. So I have a vertical stretch by 2. This is for part D, right? And then I have, I'm going down by 5. Okay? So let's talk about what the operations are happening here. So vertical stretch by 2 means what? I am multiplying y by 2. And then going down by 5 means I'm subtracting y by 5. Okay? So the reason why I'm doing the vertical stretch first, the reason why I'm doing the vertical stretch first is because if you think of order of operations, multiplication goes before subtraction. Okay? So I'm going to look at this, right? So my original point is negative 6 comma 2. So according to rule 1, right, I am multiplying y by 2. This becomes negative 6 comma 4. And then I'm going to go down, right? So then I'm using rule 1. And then my second transformation, I'm going down by 5. So I'll subtract y by 5. So this is negative 6 comma negative 1. Okay? Your order of transformations do actually make a difference. So you have to be really careful with that. Because if I actually flip them the other way, I will actually get a different result. In fact, actually, if I do that right now, if I go down by 5, 2 minus 5 is negative 3, and then negative 3 times 2 is negative 6. So my final coordinate would be negative 6, negative 6. So make sure you do your transformations in order. Again, a way to help you is think order of operations, right? Multiplication goes before subtraction in this case. Okay? So let me show you one last type of transformation, which is part E. Okay. So we generally do our flips and stretches, right? Because it's multiplication before our flips. Before our shifts. So if I look at part E, the way I want to do this is I want to do, so this will be number 1. We can do this one to be number 2, and then this one will be number 3. So I'm going to do my flip first, right? The negative's out in front, so this is flip over over x-axis, my bad. I'm then going to go to the left by 3, and I'm going to go down by 4. So I'm going to multiply y by negative 1. I'm going to subtract x by 3. And then I'm going to go, I'm going to subtract y by 4. Okay? So you, again, know your, not only do you need to know your transformations, but you must know the operation that kind of aligns with that specific transformation. So you have, our original problem was negative 6, 2. So after my first, right, I've multiplied y by negative 1, so that becomes negative 6, negative 2. I'm going to go to the left by 3 according to my second rule, so that means x gets subtracted by 3. So I'll be negative 9, negative 2. And then I'm going to subtract y by 4, so it'll be negative 9 comma negative 6. That's my final answer. Okay. This very last problem we did, part E, is kind of an indicator for things to come. So you want to make sure, again, know your transformation basics, right? So your shifts, vertical and horizontal, your stretches and compressions, which are vertical and horizontal, and then make sure you know your flips, okay? The second order of business, make sure you know all of your parent graphs. That's going to help you out, okay? Because in the next video, we're going to dive in, we're going to do a more in-depth version of transformations, okay? So we're going to end with that. Other than that, have a good day. We'll come back and finish the rest of 2.5.